Hello, everyone. This is episode 53 of Get Your Tech On, our show on all things DOCSIS. I'm Brady Volp, founder of the Volp firm and Nimble This. With us is John Downey in the flesh. So, John is CMTS technical expert, technical leader at Cisco Systems. Welcome, John. Good to have you back.
Hey, it's great to be here on my fiber optic connection. Should be a
Yes.
lot faster. Does my face and my lips match up now?
Yes, John, it is awesome. The rumors are true. You finally have fiber. We have a beautiful connection. We get to see you clearly. We get to hear you clearly. And now we just want you to look up at the camera so we can see you. See you looking back at us clearly. There you go. There's our camera.
Bam, 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 bam. They call me the Ron Burgundy of cable.
So awesome. This is fantastic. We had a lot of people at Expo asking about, like, John, when you're going to get high speed and stuff like that. And so it finally happened. And we're really excited about it. So I think everyone's going to be happy.
It wasn't questions of when you're going to get it. It was more like, yeah, I can't handle it anymore.
No, that's pretty much it. We got a lot of feedback saying, fix John's connection, do something about it, and now it's done. So happy to have that. So today we're going to talk about DAA, Distributed Access Architecture, RFI, stuff like that, pros and cons. But first, we have a question from one of our listeners. Love the podcast, so thanks. Secondly, as we know, DOCSIS 1.1 introduced BPI Plus in 2001. And they're saying, well, the certificates to support that are only good for 20 years, and then they expire. And then CMTSs will reject the device registration. So we're talking about the BPI Plus certificates in cable modems. They expire after 20 years, and we're hitting that threshold. And so this person's saying, many MSOs will have these legacy devices on their networks. Just thought it'd be good, an interesting topic on what we're doing as an industry to address that. So, John, I don't know if you know what Cable Labs is doing, but I just wanted to hear what your thoughts were on this. If
you didn't even give me a prep on this question.
Heck no, that's what this show's about. I throw you balls and curve balls and see how you respond.
Yeah, no kidding. It's funny you bring it up because this came up about a month ago with MSO here in the U.S. And we decided on our CMTS that we would have some type of global command to say allow it. Because it is going to be an issue and it's being addressed. So with that in mind, it's not going to be a surprise. So people are addressing it. And I know in our CMTS, we're going to have some type of global command to allow maybe certain OUIs, maybe an OUI, original unique identifier, with maybe a subnet mask. Because there's sometimes not, the first 3 bytes or 6 characters in the MAC address is the OUI. But sometimes it's the first 8 characters will really indicate maybe the EMTA of a certain manufacturer. So there might be a way for us to say, all right, these devices, I know they're going to be exceeding their certification, their certificates. Just allow them on because they've been working for the last 20 years. So I'm not too worried about them. The bad thing is what happens if they just quit working, right? It almost reminds me back in the day when we activated ATDMA, and we knew when we activated ATDMA, 1.0 modems would not register. And some people used that and exploited it to get rid of the 1.0 modems.
Or even 1.1
who's
modems,
to say, right? Yeah, it was actually, to get rid of 1.1 and 1.0 modems, right? So who's to say that we don't use this to get rid of older devices that should have been removed a long time ago? Like, you could use this to exploit your customers and say, oh yeah, that modem, it became obsolete 10 years ago. Right. So please, come on in, we'll ship you to a 3.0 modem, please, upgrade it, replace it, whatever.
Yeah, because
and maybe it's our way.
Yeah, the use case is you're running BPI enforce, so you're forcing encryption. When that certificate expires, that modem's it's basically not going to be able to run BPI anymore, BPI Plus. So it's not going to be able to register. The customer's going to see my modem won't be online. So from the operator's perspective, they'll say, yeah, you have to get a new modem, or you have to run a new modem for us, or you have to go buy a new modem. That is basically how it's going to go down. So it's really cool. I did not realize that you guys were actually doing something to address this issue. I know what Cable Labs is doing is they're developing, I think it's a software type of application for cable operators. So they can use that to basically go through their inventory and see which devices have certificates that are coming up and expiring, so they can get ahead of the game, contact those subscribers, and let them know, hey, your modem basically needs to be replaced, either through us, the cable operator, or through, go buy a new modem and get that online if they're letting their subscribers do that.
Yeah,
So,
yeah. The question that might come up is, why do I need BPI plus, right? Baseline privacy is critical for security of the modem. I know back in the 1011 days, we had a lot of modems that were hacked. There was even a book out that talked about how to hack a cable modem.
yeah.
There was a guy selling, I think, dongles that you could tie into the old Motorola Surfboard 1011 modem, and you could actually hack it or change the MAC address. And nowadays, we're worried more about cloning, where on the CMTS itself, it keeps track of the MAC addresses and the CPE and MAC address assignments. So you can't have the same MAC address on a CMTS, but what if you find a friend of yours that has a certain MAC address on a different CMTS? Well, CMTSs don't talk to each other. So you need something external to the CMTS, like your DHCP server, that can keep track in a database, and a way for you to say, yeah, that MAC address definitely is a clone of somebody else. That guy paid for bronze service, and he picked up the MAC addresses from someone that paid for gold service. So now he's getting a better quality of service because he cloned the MAC address. So I mean, that's another thing that we try to keep track of, is clone MAC addresses and clone modems. And if we just allow everybody to bypass BPI plus, then that's going to cause even more problems with theft of service.
Right. Yeah. So definitely, we encourage all operators to use BPI plus, and there's even more security in DOCSIS 3.1, but for the purpose of really securing your network, making sure that you're as to your point, not stealing services, and just adding that extra layer of security. So that's how we got into this whole BPI plus world. And BPI, for those who don't know, stands for Baseline Privacy Interface Specification. So there's a specification in DOCSIS. If you want to know more, go to Cable Labs and just search BPI, or Baseline Privacy Interface Specification, and there's a lot of great reading material for you there. So in the news, there's the latest issue of Broadband Library magazine is out, and I did an article in that for some interesting information I found. I've been really kind of promoting, along with a lot of other people, low latency DOCSIS. My attraction to low latency DOCSIS is I like to play fast games online, so I like to have the latency down, so my gaming is even better. But I'm not the only one. Just recently, we had the esports in Atlanta. It was this past weekend. Huge turnout on it. I actually forgot to look that up before the call to see how many people. It was, tens of thousands of people attended this in Atlanta from all over the country. I think actually from all over the world, people came in. But the bottom line, this whole esports thing is a multi-billion-dollar industry. And it's sports, so it's also, where I actually see this going is a lot of the younger generation are tuning into electronic sports, gaming sports, rather than football and baseball and things like that. So this is a growing industry. The thing is, it's really important for our industry, because what the topic of this article is how telecom operators are leveraging 5G to attract gamers. So telecoms are seeing that they can achieve low latency with 5G, and they're targeting subscribers who want that low latency and saying, if you're near a 5G hub or a 5G access point, just drop your existing service, get on 5G, your gaming experience will be fantastic. And that's one of the things they're focusing on. So please, read my article in Broadband Library at broadbandlibrary.com, get more information on that. And that tails directly into some other articles I have here, where AT&T, their next 5G network, is going live in December. So they are kind of promoting that. They're saying the initial experience won't be as fast as what 5G can promote, like gigabit speeds. But it's still going to be a big jump over 4G. We take that over to Verizon. Verizon has an article on how they're starting to show what their coverage maps are going to be for 5G. The coverage maps are sparse, and that's one of the things we know about 5G. It doesn't cover as much as what 4G does, but that's also an opportunity for cable operators because we have cable everywhere. I think that's going to be an interesting competition between cable operators and telecom operators. We at Cable Tech Expo, there was an interesting presentation that was given by one of the major MSOs that we work with, where they went out and kind of did an overlay of here's our cable plant in this city. If we put 5G cells up, what would our coverage be? And they were actually surprised with very, very little changes to their plant. They could put 5G cells up all throughout a city and get relatively good coverage just because their coax cable runs all throughout the city. And
so using the DOCSIS as a backhaul.
Yeah,
using
yeah.
the cables for the backhaul.
DOCSIS is a backhaul, but one of the critical aspects is that they have to use the LLX haul, or the low latency X haul. There's two things here. We have low latency DOCSIS for kind of gaming or any applications like that, and then we have the low latency X haul, which is required to get your latency down in order to support the low latency requirements that you need for 5G. So 5G is inherently low latency, which means you don't have that jitter, you don't have the latency, but in order to support that 5G backhaul, you need low latency X haul, or that inherent low latency in DOCSIS. So the vendors are all you guys that are making CMTSs and the network behind it seem to be on board with supporting that infrastructure. So I think we're really, really putting the cable industry in an awesome position to support 5G backhaul and also to support the gamers. And the big thing about the gamers is it's not, that's kind of what my article covers. It's not a bunch of 11 and 12-year-olds. The median gamer and I have that in my article, is mid-30s, and in Canada it's even a little bit older. It's in the mid-40s. So these are people that are making decisions about what service they're going to provide. And if you have a competitor in their area that can offer a
it's so cold
better
there, everyone
latency.
stays in.
Yeah, absolutely. So those are interesting.
They stay
things.
indoors more often, so they need to play more games.
Yep. So, and then just another article. So we just keep seeing these articles coming out where AT&T, Verizon begin land grabbing for the flashy 5G partnership. So I think this is something we have to watch in the industry, that we need to be competitive with the telecom operators and stay ahead of it all. So we're not getting behind on the 5G game, because 5G could be, we both have to have low latency. We have to as an industry be providing 5G and providing low latency, because I think all these tying together, we're going to see esports growing a lot. That's going to be just a new thing. It's already a thing. It's a multi-billion-dollar industry, but we're going to see that continue to grow. And I think the people who want to use those, want to game on our platforms, are going to demand low latency. If we can't provide it, they'll go to someone else.
Yeah, you wonder. It's 5G could be considered competition or complementary.
Yep.
It could be an extra service offering that I have. If an MSO is big enough, they might say, at what point do we get in to be a mobile provider as well, and a one-stop shop to my consumer, right, for all content. That way they can keep their content on the go, do whatever they want. I have too many cord cutters, so they're cutting video, but I need to pick up another revenue source, so maybe
5G's
mobile is the way to
revenue.
go.
Yeah.
At what point do we see the industry gobbling each other up? Like, how do we know Verizon doesn't become part of Comcast, or maybe, or you know what I'm saying, is maybe Spectrum ends up buying Verizon, or they come together as one.
Nothing
is out of the realm.
Because I think there used to be a really clear line between cable operators and telecom operators, and the line started to blur a little bit as the cable industry got into voice over IP, But now that cable operators are becoming telecom operators, they're providing telephone service, wireless telephone service, and telecom operators are providing data service, and it's just and they're providing video service. The lines are so blurred. I wouldn't be surprised if what you're saying comes true, John. That
I
at some
think it's
point
because of so
we could
much,
have a
yeah, so
merger.
much video, so much video is becoming IP, over the top. Um, Legacy video is kind of going away, and the younger generation, which is becoming cord cutters, they want to do everything over the top. They want to be able to just download and watch whatever they want to watch. We would always debate and argue about a la carte programming, and the cable operators like, I can't do a la carte because PBS, no one would pay for PBS. PBS might be bundled with all these other programs like ESPN and sports channels that you're paying for, and it kind of subsidizes all these other channels. So I'm able to give you 100 channels, even though you only watch 10. I can give you 100 channels for a certain price. And everyone's like, but I only watch 7 channels. I don't want to pay for 7. Well, that's actually coming to fruition now, isn't it?
Yeah,
With
now
on
because
the
now
go
we
and over
have
the top.
And now we have Apple that has their own TV service. We have
You
Disney that came out. They had 11
yep.
million users sign up within their
Hulu
first 2
TV,
days, and then they got
Amazon
hacked,
Prime.
and everyone's account got hacked after that. But I still think, to your point, yeah, all these services, originally the content providers did not want to break up and start divvying out their stuff, but now everyone is in a free for all. So
Yeah.
I think the a la carte days are upon us.
Content is still king. If someone puts out good programming, customers want it. And maybe they only want it for the 3 months that content is actually active.
Yep.
It might be a series that happens to be on for 3 months, and it's okay, I'll pay for 3 months and then move
or you
on to the next one.
or I think what's happening a lot is a lot of like HBO will offer 3 months free, and so what people do is they sign up for that 3 months free. They binge watch everything, and
Yeah.
so things are changing.
Yeah.
So that's in the news. I think now let's talk about DAA, Distributed Access Architecture. So I talked to a lot of operators, and it's interesting because what you read is DAA is taking off, everyone's doing R5, but the reality is not so much. We haven't things have not gone as quickly as what we had expected them to go with deploying R5, remote PHY, and things like that, and that's because there have been some challenges. Now, the alternative, there also have been a lot of good things that come with R5, DAA deployments and stuff, and I just like to get your opinion on what you're seeing from that standpoint.
So first, distributed access architecture means, and I simplify it. I said you're moving from an analog, amplitude modulated fiber light to digital, pure digital, ones and zeros. So that's, you could just say analog fiber to digital fiber, and that's DAA. That's also called SYN, the Converged Interconnect Network. So when someone says my SYN, they're really talking about digital fiber link, transmit to receive. Let's look at why customers might not be able to go to a digital fiber. If you go to digital fiber, all your analog content has to go away.
Mm-hmm.
So if you're still carrying a channel 2 analog, well, that has to go away. If you go all digital, meaning digital QAMs, the R5 device or remote MAC-PHY device has to generate that RF signal, and it's going to be usually in a QAM type of format or OFDM, DOCSIS 3.1. Now, every device out in the field, this customer premise equipment, that has to be able to receive it. So what happens when you have older TV sets, older set-top boxes? What do I do with those? Do I trash them? Do I provide everybody with a digital to analog converter, a DAC? So that becomes an issue. Maybe it's an upsell positioning. A lot of systems have gone that way already anyway. So getting rid of all the analog content is great and all, but then you have to look at, what about test equipment, test signals, leakage, CW carriers for balancing. So the digital equipment has to be able to create all that. The node has to be able to produce all those RF signals. Your leakage signals, your maybe a CW pilot tone, maybe an AGC pilot for an amplifier, automatic gain control, um, maybe an out of band signal for a set-top box. What else can you think of? All my qualms, my 3.1, my 2.0, my DOCSIS, all my MPEG-2 video qualms.
Yep. So I would say that, there is an alternative solution to that the operators offer, which is vendors offer, which is it's the remote PHY shelf. So if you do a remote PHY shelf, you can still offer those analog solutions, but I don't think you get the same trade-off of what you do when you go to a remote PHY node, where you're actually pushing all those digital signals out. So to your point, the initial trade-off you have when you go to remote PHY is those analog signals that you want to be doing is going away. You also lose a lot of functionality, like your legacy sweep systems you don't have anymore. Your legacy test systems that you're typically using, maybe like a return path monitoring system and forward path monitoring system. A lot of those systems are immediately obsolete. So investments that you had become empty immediately.
Yeah. The remote PHY shelf idea would be, what if I have a hub site out that's 50 miles away? Instead of having duplicate equipment out in the hub site, I'm paying for HVAC, real estate, that building, security. There's a lot of stuff you're paying for a hub site that you might be able to just remove it.
Mm-hmm.
I might be able to do a shelf and get rid of all of that extra equipment in there and just run a digital fiber to a shelf, and that feeds my existing analog fiber nodes out in the field. Yeah. So I can extend, maybe get rid of redundancy of equipment and move everything to a central location where I have my CMTS core, I have all my video content, I have my satellite dishes, and then I run digital fiber 50 miles away, 100 miles away, 1,000 miles away. There's no reason why I can't do that with digital fiber. That's one of the powers of digital fiber, right? Distance, cost of the SFPs, the shared form factor pluggable. Is that right?
SFP? Yeah.
Yeah.
I think it's it.
Yeah. So, I mean, it's cheaper than analog receiver and transmitter.
Yeah. So we have a couple comments from the live chat. First of all, we got greetings from Zimbabwe, from Tapawakawe. I probably messed up your name. Apologize for that. And To-Dos is friend of the podcast we know well, is saying, John, no issue. He's suggesting the RF overlay for out of band OOB over NDF, NDR, and FFT. So he's suggesting that we could handle that. Although I'm not sure we could handle all the analog video on the out of band.
Yeah, I don't like the idea of an analog overlay. Now you have to run two different wavelengths of light or two different fibers. The beauty of digital fiber is you're moving the chipset, the Broadcom or Intel chipset, to the node itself. So in essence, you're moving the head end further out, closer to the customer. So your MERs are really great because it's digital fiber. When you run an analog link, the link loss and the link budget dictates your MER. So the longer the fiber link on an analog link, the worse the MER will get. So what happens if you take an analog link and combine it with a digital link? You're only as good as the worst link. So unless you can filter out the noise being generated on the analog link, you don't want to combine two links together. So doing a digital fiber, coming out with RF from the digital chipset, and then combining that with the output from the analog link, you just created all that noise from the analog link, unless you can figure out how to filter. And you can filter it out. But I mean, to me, getting rid of the analog is the way to go. I mean, I think it's like not ripping off the Band-Aid fast enough. You're slowly ripping off the Band-Aid. I'd rather just rip it off and go.
No, I think that's the objective of operators, is go to an all digital, all IP system when they're going with remote PHY. I think that's the end goal. And there are solutions that test equipment vendors have to do things like sweep and ingress and even like what we do with return path spectrum analysis with RPDs, that bake it in all digital solution. There's even stuff like Bo Cronbach with his Cronbach tracers that he offers for European operators that must carry FM radio that allows them to directly send that over. He also has some cool test equipment solutions and stuff. So he offers cool things as well that all occurs
So
over
he's basically
the
taking
NDF.
the 88 to 108 megahertz FM
Yep.
radio and then digitizing it,
And he
right?
sends that over
Then
the out of band, the
yeah,
NDR, NDF,
yeah,
and stuff. Yeah, so he's doing a lot
yeah.
in that space as well. So I think there are solutions for that, but it is something that you still have to buy. It's additional hardware that you're buying and putting your head end, or additional software that you're buying and putting in your head end. Because, again, to your point, the legacy analog hardware that you had for doing things like sweep and ingress detection and egress detection will just no longer work with a digital going over the CIN. So
Yeah.
I think that's one of the
The
challenges
other
that people run
thing is,
into.
yeah, people ask about DOCSIS 3.1. Is it required to do remote PHY? And I'm like, no, it's actually just complementary. If I can do a remote PHY, do a digital fiber, I get better MER, which can help promote higher modulation schemes with DOCSIS 3.1.
Yeah.
If I do digital fiber, there's many cases I can do 4K QAM on the downstream, and it works perfectly fine. If I'm doing node plus 3 amplifiers, then maybe the third amplifier, modems after the third amplifier, have a lower MER. So yeah, maybe they drop down to 1K QAM. But I have profile management that can dictate which modems are doing which modulation based on the MER readings that are reported back to the CMTS. So I mean, yes, they are definitely complementary, the remote PHY DAA with, say, DOCSIS 3.1.
Yeah. So I think that's what it comes down to, and what I've had operators ask me is, what is the big benefit of going to remote PHY? So they understand what some of the challenges that they're going to have. They have to get rid of analog. They have to maybe invest in some new equipment and stuff like that. But what's the big bang for the buck that they're going to get once they get that RFI, that DAA based RFI node deployed in the field? And is it just improved, upstream MER and downstream MER signal quality? Is that the only thing that they get?
No, I mean, like we mentioned, distance. You can go much farther distance.
Mm-hmm.
The SFPs that I've seen on the market, or the longest one is 80 kilometers. But normally in a digital realm, you're going to go to a switch, a router, maybe to another switch and a router. You have multiple hops. So an 80-kilometer SFP, and this is interesting because I talked to one of our optics guys and I said, does an 80-kilometer SFP have a higher output power than a 20-kilometer SFP? He's like, no, ironically enough, they're all putting out like 3 dBm, 2 milliwatts, somewhere in that range. But the receiver is more sensitive.
Yes.
So you're paying more money for a higher rated SFP because the receiver is more sensitive, not because the transmitter is putting out higher power. So that's good to know. So the 80-kilometer might end up going, say, 50 kilometers, but then you have loss because of all the hops in between. You have delay in between. You have splits. But then you might be going, say, 10 hops, 80 kilometers. So you could be going 10 hops, 50 kilometers apiece. That's 500 kilometers. Or maybe you just you're doing some type of EDFA, the erbium dope fiber amplifiers, where you're actually going 200 kilometers with one point-to-point link. So I mean, distance is a big one. I can go a lot farther distance. By going further distance and having pure digital lineup, I might be able to remove hub sites. I'm like taking my entire content from a head end and moving it to a smaller area. So I just eliminate maybe an entire hub site. I have better performance, better MER. It's not just downstream, it's upstream. I like the idea.
Yeah, but what about
Upstream
bandwidth?
MER.
Because I look at bandwidth, and if you have analog lasers, you're probably going to be pretty limited in bandwidth in return on how high you can go. Say, maybe 85 megahertz with an analog laser, but maybe you want to go to 200 megahertz because that's your long-term plan.
You're not going to do it with analog.
You're not going to do 200 megahertz with an analog laser.
No. And even 85 megahertz, we're always talking about laser clipping and stuff like that. With a digital laser, you don't have laser clipping. Analog laser, you have laser clipping. whether it's from RF signal or from noise, which is like an RF signal, any type of noise. Uh, so if I do a digital laser, then I don't have to worry about that. I might have to worry about an A to D type of, or a D to A or A to D type of overdrive, compression. But it's the laser I'm worried about. And an analog laser, we have BDR and EDR, so baseband digital reverse and an extended digital reverse, enhanced digital reverse. That's good for 85 megahertz upstream.
Mm-hmm.
But I haven't seen any type of digital-esque laser for 204.
Yeah.
I've heard of one customer that told me they were going to try to do 204 upstream because it is part of DOCSIS 3.1 spec, and they were going to try to do it on an analog laser. I'm like, ooh, good luck.
Yeah, I think it's just going to be way more sensitive in an analog laser. So when, from my perspective, when you start investing in RFI, you're really starting to invest in your future. As far as, you know that you're going to have the capacity to go to 200 megahertz or maybe 600 megahertz when we start looking at an extended spectrum. An extended spectrum says that, maybe we go to 1.2 gig, 1.8 gig even at some point. And so when you start having that and you start thinking, at some point we're going to have a lot of different things going on where we start to have a more symmetrical network. In that symmetrical network, we have, a much, much different perspective of what end users are going to be as far as streaming data in the upstream, receiving data in the downstream. And in order to achieve that at, say 5 years in the future from now, that's going to require a radically different network than we have today. We talk about getting rid of diplex filters or having a fixed diplex filter at the 600 megahertz band. So, we have a 600 megahertz return, a 600 megahertz forward, maybe even a broader forward than that. And that I think is where R5 really becomes something that you want to have in your network. And that's the type of planning that you would look at.
Also, R5 is the first step to evolve the network into cloud.
Virtualization.
So once all the RF is removed from your CMTS, the CMTS doesn't have to be a CMTS anymore.
Yeah.
Basically, it's all optical outputs. So I could have a data farm running what looks like iOS, and it could be cloud native. So I could have a centrally located bunker running servers and running this iOS, feeding optical switches and routers out to all my RF locations. Those are my remote PHY, remote MAC-PHY devices across the country. So in theory, I could have a bunker in Salt Lake City, in the salt mines, and with Ancestry.com, or whoever is out there,
yeah.
23andMe or whatever those places are, and then I could have a fortified location with backup generators and redundancy, and I just have redundant fiber optic paths going out to my locations that are doing the RF. There's no reason why I couldn't do that distance. Now, if I'm worried about latency and delay, yeah, I could put the scheduling and what we call flexible MAC architecture, FMA, and remote MAC-PHY or distributed CMTS or some type of solution or mixed solution to get that delay and latency down a lot lower.
Yeah. So
by the way, yeah.
No, I think your DAA now takes us to really the next level of where the industry is going is with virtualization, and I mean the ability to put your CMTS in a server, whether it's to your point in a bunker or in the AWS cloud or just pretty much anywhere you want to put that CMTS, reduces the basically the requirements that you have in current head ends today or hub sites, from cooling, powering, if a hurricane comes in and takes it out, or an earthquake takes it out, that survivability is so much improved when you're able to put that data center somewhere where you have backups, you have multi-tenancies, so that data center is replicated, that CMTS is basically replicated. It's in a completely different environment. And because we're moving to a really data-centric world where people depend on that data so much more than they did before, virtualization makes incredible sense. And DAA makes that possible. We can't do that today with analog links.
Yeah, and once you have this network and this spider web network laid out, you could look at capacity planning totally different as well. You could look at a RF remote PHY node and say, oh, this is really highly congested. Let's use the resources combined with another RFI node that's underutilized. So we can reassess and reallocate resources on a node by node basis. And just by spinning up another server that happens to have more resources. And it's almost like we can share better the resources. Whereas when you have a hard CMTS and another hard CMTS, it's not like you can say, let's just move a fiber node from one CMTS to the other fiber node or to those CMTS. Yeah, you can do it with RF guys, move a coax over, but it's a lot more planning that comes into play there. Whereas when you're in a digital realm and virtual and cloud, you could do that with some keystrokes. You could do that automated. You could automate something that just look at capacity and have certain threshold and say, hey, when I hit 75% threshold this time of day, let's move it over to a cluster that's less utilized.
Yeah. So, and that gets into orchestration. So today, the orchestration of adding capacity to a CMTS is calling your vendor and saying, I need a new blade or I need a new CMTS, and submitting work order or purchase orders and waiting for the equipment to come in. And I mean, it can be a week or multi-week or multi-month process. Yeah. Orchestration in a virtualized environment, to your point, can be setting up a rule to say when you hit 80%, adding that additional capacity in a virtualized environment, which could take a matter of minutes or even less. Yeah. And I think as we start to understand that as an industry, to me, it's incredibly exciting because, I see that capability and it's just awesome. So I'm really excited about virtualization.
And that whole idea makes some people squeamish, or, our whole cable industry is kind of aging out. You go to all these conferences, we're all getting really older, but there's no new blood coming in. Yeah. The new blood is in the cloud, Kubernetes, understanding web, digital side of it. But, with that, in the same breath, I see us looking at extended spectrum out to 1.8 gigahertz. I'm like, ooh, RF is sexy again. Yeah. I need to be able to look at RF and understand, when I go to 1.8 gigahertz in the downstream, by the way, is to open up the upstream. We're not just open up the downstream for just downstream. We don't really need more downstream. But if I need to open up the upstream, it eats into my downstream. So I have to open up the downstream to 1.8 gigahertz. If I do that, I have to have maybe some RF expertise and testing and test equipment. And it starts getting sexy again. I need Ron Hranick to be out there to evaluate all my cable plants and make sure 1.8 gigahertz is going to work. But all the taps, everything.
Will you be able to get Ron Hranick to say it's sexy again?
He's bringing sexy back.
All righty.
With that
said, I think we covered a lot of what I wanted to cover. Anything else? I mean, we talked about some of the downsides, which I think they're all addressable. The upsides are less tangible because you're really preparing for your future of where you're going, and I think that's the big thing. The immediate gain you get with DAA or RF remote PHY, we've seen on slides. We've talked about that in past episodes. Yes, you get immediate improvement on MER for the cable modems or SNR. SNR is MER. We always talk about that. Yeah. For both the downstream and the upstream, but that's good. Any RF guy is going to like that. However, I think the big bang for your buck, because you don't want to spend all that money just to say, oh, I'm getting better MER and stuff like that. But I think the big bang for your buck is what we're talking about. It's the long term. It's being able to do virtualization, orchestration, and reduce head end costs, and even eliminate hub sites like what you're saying. Can you think of anything else that we haven't covered?
Well, we mentioned, no laser clipping, and that is a concern, right? Even on the downstream, customers started adding more RF channels, DOCSIS 3.1 to their existing lineup in the head end. They may not have taken into account RF loading into the laser itself. So every once in a while, you can get downstream laser clipping and not even realize it. It could have been when emergency alert system EAS kicks in and all your your signals line up, your sync pulses line up, and now you get laser clipping during an EAS scenario. You don't have that with the digital fiber, so you don't have laser clipping because you're not doing analog or amplitude modulated light. I used to call it intensity modulated light, right? Because you're changing the intensity of the light even though you can't see it.
Right.
It's an invisible wavelength to your eye, 1310 or 1550 or any wavelength around there.
Yeah, well, if you hold the fiber up to your eye, after a while you won't be able to see anything.
It'll come out the other eye.
Yeah.
It loops around. It's a refractive and reflective nature. So I mean, I think in that regard, you don't have the laser clipping, which is great. You're loading digital fiber. You can take, and I say this all the time, you can take 10 gigabit per second fiber links, combine it into one 100 gigabit link. So we can combine digital fiber in the time domain. Just go to a faster link. You can't do that with RF.
Mm-hmm.
You can't take an RF cable, combine it with an RF cable, and then come out with clean signal.
It's 3 dB more power.
Yeah, you could do that. If it all adds in phase, as long as the two lengths are exactly the same, they'll add in phase.
Yeah.
If not, they add out of phase, and then you get 0. It adds out of phase.
But some people will think you can do that. Combine 2 RF, you can get 3 dB more power. They don't understand that there's phase cancellation and stuff there. So
I had a customer do that when they had downstream RF levels to the house were bad, and the tap had an empty port. They would hook up 2 ports and combine them together.
It does not work that way. Sorry, guys.
and ironically enough, as long as the 2 cables off the port were exact same length to the splitter used as a combiner.
But you have to have a perfect splitter, too. The splitter has to be a phase match splitter.
And what happened was they would gain some signal in the downstream, but when the upstream split and then combined back in the tap,
it's a mess.
You couldn't guarantee they wouldn't be out of phase.
Yeah.
So, yeah, it was a real mess. It was like, yeah, you don't do that. If it hurts when you do that, don't do that. So I was thinking, another advantage of the digital fiber, we said distance, we're not going to get laser clipping. I had a customer come to me and say, well, what type of MER would you expect if you do a remote PHY? I said, well, technically you're putting the Broadcom or TI Intel chipset at the node itself. And I would expect like a 50 dB MER downstream and a 40 dB MER upstream, which is awesome. But once you go through the amplification of the node itself and the noise figures and everything added back in, downstream you might be seeing mid 40s, upstream still pretty close to like upper 38s, 39s. When we look at DOCSIS 3.1 being 6 dB more robust than say DOCSIS 3.0 in the breakpoints, I could run 1K QAM in the upstream, 4K QAM in the downstream in a lot of situations. So, I mean, performance is definitely there. I'm trying to think any other advantage besides being the stepping stone to cloud and virtual, right?
Yeah, I think those are it. I mean, we're investing in the future.
Yeah,
it's an investment in the future of where we're going. So
yeah, and then we start looking. You mentioned upstream, 204 upstream. I like the idea of 204 upstream because there's CPE that I can buy today. There's DOCSIS 3.1 modems I could buy today that can support 204.
Yep.
If I say, oh, let's do 396 on the upstream, I'm like, well, what good is that if I don't have the cable modem?
That can support it.
I don't have any devices. Yeah.
Right. All right. Well, John, I think we've covered this topic pretty well. So we'll wrap this up. John, thanks for your time today. This was a good episode. Our next episode is episode 54 in December. Damn. We're half the way to 100 already. More than halfway. So we do our best every show to try to bring good technical content to our audience. If you like this and you're watching on YouTube, please hit the subscribe button and hit that bell so you get notifications when we broadcast. And if you're listening to us on the air, just subscribe on your favorite podcaster. John, have a good Thanksgiving. And everyone else, if you're in the U.S., celebrating Thanksgiving, have a good Thanksgiving. Enjoy your turkey. Thank you so much. We'll be here next month. Take care, all. Bye-bye.
All right. See you.